Hey boys and girls, so today we're going to be going over Unit 9, Lesson 7, which is Unknown Angles. Before we get started, just make sure that you have your name written down at the top, and we can begin. So as we look at the directions for the do now, it says solve the following equations. So as we look at part A, we want to solve 2x equals 14. So it looks like I'm solving for the variable x. I'm just going to highlight that out. So if I want to get x by itself, whenever I have a number and a variable mushed together, mushed is multiply. So the opposite of multiply is divide. So I'm going to divide both sides by 2. This cancels out, and x will equal 7. That's how I would solve an equation like A. Now let's look at B. This equation says x squared equals 9. Okay, I'm still solving for x, so I'm going to just highlight that out. But this time I want to get rid of a square. So what's the opposite of square? Square root. So I'm going to take the square root of both sides. That cancels out my little 2. All right, so now all I'm left with is x equals, well, what's the square root of 9? Yeah, it's gonna be 3. And then as I look at part C, it says, how do you think we would solve sine of x equals 1/2? And then it has a little hint. It says, look at your calculator. All right, so as I look at this bar underneath that has a hint inside, it says, I want to use sine to the -1. That's actually said as the sine inverse. All right, so I want to use sine inverse, cos inverse, or tan inverse when solving for an unknown acute angle. So if I look at part C, x represents an unknown acute angle. Think of all the questions we've been working on so far. It said find sine of 30, tan of 50, cos of 102. You know what I mean? So I know when I don't see that angle measure, that's what x is representing. So I'm going to highlight this as well. Well, how do I get x by itself in a question like this, you ask? Oh, don't worry, I've got you. So instead of writing sine of x equals 1/2, I'm going to rewrite this as sine inverse of 1/2. Yeah, you heard me, write that down. Sine inverse. And this is how you would get it on your calculator. So here I go. Whoop, and turn it on. The first thing you want to do before you start punching any buttons is pressing mode. And I want to make sure that I'm in degree mode. If I'm not in degree mode, I'm going to get all the wrong answers. So make sure you're in degree mode before you get started. All right, now I'm going to go back to the regular screen. And if I look at the sine button, do you see how right above it in blue, there's that magic sine inverse function? Yeah, so since it's a blue word, I have to press this blue button to activate it. So I'm going to press second sine, and look at that. Now it looks exactly how I wrote it on my paper, sine inverse. Then I want to type in 1/2. A lot of you right now probably want to do alpha y equal, and that's fine because that brings up a fraction. I'm going to press enter, and we know that fraction is 1/2. I want to just arrow out and close that fraction off. Press enter, and I can see the answer is 30. So what's the sine inverse of 1/2? It's 30. So if I want to fully answer this question, what does x equal? X equals 30 degrees. So sine of 30 degrees would have been 1/2. All right, this is what we're going to be working on today. So let's scroll on down here to example 1. Let's get this party started. As we read the directions, it says find each measure of the marked acute angles to the nearest degree. I always underline the question because I want to make sure that I've answered it completely before I move on. So here we go. Find each measure of the marked acute angles to the nearest degree. Don't forget about that part at the end. Well, as I look at all of these triangles, if I'm looking for a missing angle measure, you guys are probably thinking right now to use SOHCAHTOA just because that's all we've been working on. But the only reason I'm allowed to think trigonometry, that's SOHCAHTOA, is because I'm dealing with a right triangle. All right, so because I have a right triangle, I'm allowed to use that trig, that SOHCAHTOA. Let's write it down. SOHCAHTOA, SOHCAHTOA. All right. And I'm ready to rock. So I'm going to just first identify what I have so I can figure out what I need to do to solve this question. I know that right across from that reference angle, that's angle A, that's what I'm solving for here, that would be the opposite side. I know that directly across or opposite my right angle is my hypotenuse. And I know that whatever's left over has to be my adjacent side. Adjacent means next to, and I can clearly see that 13 is right next to angle A, so I know I'm good to go. Now I want to see what I have. I have 20 and 13. That's going to be my adjacent and my hypotenuse. So if I look back, what uses the adjacent and the hypotenuse? Yeah, it's the cosine function. So that's what I want to solve, or use, I should say, for part A. So it's going to be cosine of the angle, but right now my angle is A. I don't know what it is, and that's okay. So I'm going to find cosine of A. Cosine is adjacent over hypotenuse. All right, the adjacent is 13, the hypotenuse is 20. So this is going to be 13 over 20. Now don't forget what we just went over in the do now. You should not be trying to cross multiply at all, boys and girls. I'm looking for my missing acute angle. If I'm looking for an angle, that's not going to be cos, it's going to be cos inverse. I want to use that inverse function. So I'm going to do cos inverse of 13 over 20, close this off. All right, and I'm just going to type it into my handy dandy calculator over here. So again, if I want cos inverse, it's in blue, so I have to press the blue button to activate it. All right, again, I'm going to do 13 over 20. Now, this is just another way to type in a fraction. I know that this is really the division symbol, so for me, it's just quicker for me to type in 13 divided by 20. If you want to use the alpha y equal, that's totally fine, but both ways are correct. I'm going to press enter, and I get this big decimal, and that's okay. I'm going to just move this over to the side and write it down. So I see my answer is 49.4583 ... All right, I'm going to just stop right there because I'm about to get my final answer, and this is when I want to round. If I want to round to the nearest degree, I'm going to just underline that space. So is it going to be 49 degrees? Is it going to be 50 degrees? I don't know. I got to look at the neighbor. He's going to tell me. 5 or above, give it a shove. Is he 5 or above? Absolutely not. So is he getting a shove? Absolutely not. So I'm going to stay at 49 degrees. But don't forget, 49 degrees is my reference angle, which was A. So really A equals 49 degrees. Let's look at part B. I'm going to just follow the same steps. I have a right triangle. I'm looking for a missing angle. I'm going to use trigonometry to do that. What's right across from my reference angle? 40. So that's going to be my opposite side. I know that directly across from my right angle is my hypotenuse. And again, that side that's left over is the adjacent. It's the next to, and I can see that this is clearly next to B. Now I want to go back and circle the numbers I'm going to use. That's going to be my 40 and my 42. Well, that's the opposite in the hypotenuse. What trig function should I pick? Boom, bam, there it is. Opposite hypotenuse, it's going to be sine. So let's write that out on the side here. Sine of my angle, right now my angle is B because I don't know what it is. So sine of B is again going to be the opposite over the hypotenuse. That's going to be 40 over 42. And if I'm looking for the reference angle, I'm going to use an inverse function to find it. So this is going to be sine inverse of 40 over 42. Let me grab my calculator. Let's type it in and see what we get. So again, I'm doing second sine of 40 over 42. Close it, press enter. And again, I'm getting a decimal, but that's okay, boys and girls. I'm just going to write it down. It's 72.247 ... Okay, this is going to now be my final answer. So I know if I'm rounding to the nearest degree, I really just need the 72.2. All right, I could have stopped right there. Again, I have to decide. Look at the neighbor. 5 or above, give it a shove. Is he 5 or above? Nope. So is he getting a shove? Nope. So this is going to stay 72 degrees, but don't forget, it's angle B. It's B that's going to be represented by 72 degrees. And then last but not least, let's look at part C. Again, I want to just see what I have. So right across, right opposite C is the 14. So that's my opposite side. Right opposite or right across from my right angle is the hypotenuse. And then last but not least is my adjacent side. It's what I have left over. All right, it's next to my reference angle. I want to go back and see what I'm working with here. 14 and 29. That's the opposite and the adjacent. What uses opposite and adjacent? That's the tan function. So I'm going to write this down. Tan of the angle. Right now my angle is C because I don't know what it is. That's again going to be my opposite over my adjacent, which is 14 over 29. I'm looking for my angle, so I want to use an inverse function to do that. So I'm going to do tan inverse of 14 over 29. Grab my calculator, type it in, and see what I get. So second tan of 14 over 29, close it, press enter. And again, I'm getting a decimal, but you guys have already seen that that's okay. So it's going to be 25.769 ... All right, again, I want to round to the nearest degree. So is it going to be 25 or 26 degrees? I don't know. You tell me. Let's look at the neighbor. Whoop. 5 or above, give it a shove. He is 5 or above, so he is getting a shove. Kick him with a boot. So he's going to move from 25 to 26. So this would be 26 degrees. And again, that's my reference angle. That's what C is going to be represented by 26 degrees. Last but not least, it says once you have found the measure of one acute angle, like I just figured out what A is going to be in part A, it says how can you find the measure of the other acute angle without using trig? Oh, well, that's going to be easy. If I'm looking at degree measures in a triangle, well, how many degrees does a triangle have? Yeah, 180 degrees. So if I know what two of the angles are going to be, I can easily find the third. Right? I would do 180 minus what I have. So I'm left with that one angle that I didn't have. All right, so let's write that down. I'm going to say there's 180 degrees in a triangle. Silly goose. That's what I would do to find that missing angle. But that's not the only method that I could use. Squiggle, squiggle, squiggle. All right, I also have learned by watching all of these amazing videos, following along, taking all the notes, that two acute angles in a right triangle, yeah, they're going to be complementary. Does anybody know what that word means? It's super fancy. Yeah, that means that they're going to add to 90 degrees. All right, so that's another method I could have used to find that missing angle. If I know that A is 49 degrees, well, 49 plus what number is 90? All right, that's another method because, again, together they are complementary. Killing it, boys and girls. Meet you on the next. All right, example 2. Mr. Shapiro was walking through a forest when he came upon a sizable tree. Mr. Shapiro estimated he was about 40 meters away from a tree when he measured the angle of elevation between the horizontal and the top of the tree to be 35 degrees. If Mr. Shapiro is about 2 meters tall, determine how tall the tree is to the nearest meter. There's a lot of important information here, so I'm going to read through the question one more time, and now I want to start marking where those important key numbers should be on my diagram. Mr. Shapiro was walking through a forest when he came upon a sizable tree. Well, here's Mr. Shapiro. Here's his sizable tree. Mr. Shapiro estimated he was about 40 meters away from the tree. Well, here is Mr. Shapiro, and here is the tree. So I'm thinking that this distance right here should be that 40 meters. All right, so I use the 40. I'm done with it. I'm going to keep reading and move on from there. He also measured the angle of elevation between the horizontal and the top of the tree to be 35 degrees. Well, here's the horizontal. Just like you guys know, the sun sets on the horizon. That's a straight line left to right. So from the horizontal, whoop, all right, and the top of the tree. So here's the horizontal, here's the top of the tree. We know that that angle of elevation should be 35 degrees. It's already marked for me, so I'm going to cross that off and move on as well. Angle of elevation, I just want to highlight that out quickly because that's a really important key word. I know that it's already marked for you, but think of an elevator, right? You normally get in to go up. So this is going to be his line of sight, and then he's whoop, looking up from there. All right, it says if Mr. Shapiro was about 2 meters tall, well, here he is. I'm going to say that this is 2 meters. That's going to be his height from his feet to the top of his head. I just used the 2, so now I'm done. Here's the question. I want to always underline my question. It says determine how tall the tree is to the nearest meter. All right, on the side, I'm going to put an X here because this is going to be my goal for the question. I want to see how tall, right, from top to bottom, this tree is going to be. Now, this is a tricky question because if I'm looking at the triangle that they've almost highlighted out for me, I'm actually going to go over it again myself. I have to see what numbers I already have and what numbers I still need in order to solve this question. Well, I know that, again, the distance from Mr. Shapiro to the tree is 40 meters. So guess what, boys and girls? I can just actually elevator that number right up to the top. So I know, again, this distance on the base of my triangle here is also going to be 40 meters, okay? Because it's still the distance from Mr. Shapiro to the tree. So this is one number that I want to use to solve this question, all right? This 2 meters, you're probably wondering, well, that's not on the triangle, so how is that going to apply to the question? Well, it's going to be the same thing. Don't forget, if Mr. Shapiro is 2 meters tall, I can just elevator that over to this side of the question. So I know this height as well is going to be 2 meters tall. Well, the question says, how tall is the tree? Well, if I know that the trunk of the tree is 2 meters tall, now I really just need to figure out what this top piece, this top height of the tree is going to be, so I can add these babies together and get the entire height, all right? So now I'm gonna use trig to solve this question. Well, guess what? I can only use trig that's SOHCAHTOA on right triangles. Is this gonna be a right triangle? Is it legal for me to add a right angle in the corner of this tree, in the corner of this triangle here that's being formed? Yeah, I can, because guess what? When you guys go outside and you look at trees, aren't trees normally perpendicular with the ground? Absolutely. There's not a lot of trees that I see that are growing out into the side on a slant. They're typically perpendicular with the ground, okay? And don't forget, this is a real life question, so you got to read into it. So because this is a right triangle, I can use trigonometry on it. So I know 40 is one side of the triangle and x would be the other side. So using my reference angle, the angle that they gave me, that's my 35 degrees here. I know that x is right opposite. It's right across that 35, so I'm going to write opposite here. I know that, again, directly opposite or directly across from my right angle is going to be my hypotenuse, which has no number, and that's okay. So that means whatever is left over has to be my adjacent side. It's got to be right next to my reference angle, and it is. All right, so now I want to just write at the top of my paper here, SOHCAHTOA. Right, we got our SOHCAHTOA here. And I want to see what trig function uses the opposite and the adjacent. It looks like it's going to be the tan function, all right, for that opposite and adjacent. So on the side here, I know I'm really finding tan of 35 degrees. It's always the trig function with the degree measure. So tan of 35 is going to be opposite over adjacent. If I look back at my question, I can see my opposite side is x and my adjacent side is 40. And now I'm ready to rock. If I have a fraction on the right-hand side, I can make the left-hand side a fraction as well by putting that over 1. Now all I got to do is cross multiply and solve. I've set up a proportion here. Well, what's x times 1? It's just going to be 1x. And I always want to show my work. When I type this in the calculator, I'm really typing in 40 times tan 35. So I want to write that down. I'm going to do 40 times tan of 35 degrees. Let me grab my handy-dandy calculator and actually type that in. Again, I'm doing 40 times tan of 35 degrees. I want to close that and press enter. Okay, I'm getting a pretty big decimal. That's okay. I'm going to write that down. So we get x equals 28.008301 ... All right, I am not rounding here whatsoever because this is not my final answer. When it says round to the nearest meter, that's when you're about to finish the question. I am not finishing the question at this point in the game. I'm just figuring out what this length of x is going to be, just this top piece of the tree. So now I'm going to add that onto my diagram. I know that x is going to be 28.008301, right, ... But if I want to find the height of the entire tree, well, here's the top of the tree, here's the bottom of the tree. So I'm really going to add that 28 and that 2 meters together to get the entire height. So at the bottom of my paper here, I'm going to write that down. I'm doing 28.008301, ... That whole big decimal, I want to add the top onto the bottom. The bottom was 2. And when I add those babies together, I get 30.008 ... At this point, this would be my final answer. I'm ready to round. So again, I want to round to the nearest meter. So is it going to be 30 or 31? Well, let's look at the neighbor and check. Whoop. 5 or above, give it a shove. This is not 5 or above. He's not getting a shove. So my final answer for this question is going to be 30 meters tall. All right, that's how tall the tree is going to be. I'm going to just highlight that out so it's very clear that this is my final answer for this question. Now, if we jump down to part B, we got an extra piece here to answer. It says, Mr. Shapiro was impressed with this tree until he turned around and saw an even bigger one, which was also 40 meters away, but in the opposite direction. So this time as I'm reading, I want to add on these key numbers just to speed this up a little bit. So it says, Mr. Shapiro was impressed with this tree, the tree that he had before, until he turned around and saw an even bigger one, but it was also 40 meters away. So here's Mr. Shapiro. We know from before he was 40 meters from the smaller tree. He is also going to be 40 meters from the larger tree as well. All right, so I just used that 40. I'm going to cross that out and move on. Wowza, he said. I bet that tree is at least 50 meters tall. So he means from the top of the tree to the bottom of the tree. He thinks that this entire height is going to be 50 meters tall. I used the 50, I'm going to cross it out and move on. Then he thought for a moment, if it was 50 meters tall, I wonder what the angle of elevation is going to be. Well, let me highlight that out. We went over this in part A. Angle of elevation is going to be his line of sight, which is right here, and then looking up to the top of the tree. Elevation is like an elevator. We want to look up to see what that angle of elevation is going to be. All right, so he's thinking that this angle that's being formed right here is going to be, well, actually, we don't know. He said, I wonder what that angle of elevation is going to be. All right, so part A, it says, do you think the angle of elevation to the taller tree, so do you think this angle is going to be greater or less than the angle of elevation, the 35 degrees from before? Do you think this angle is going to be more or less than this guy over here? Yeah, it's definitely going to be greater. It's going to be more. So let's fill that in. It's going to be greater. Explain how come? Well, it's going to be greater because the tree is taller. He has to look even higher to see the top of this tree than he did to see the tree from earlier. All right, so that makes sense. If I have to look higher up, this angle would be bigger than the original. So now as we look at the question at the bottom, it says determine the angle, I'm going to underline the question, determine the angle to the nearest degree that Mr. Shapiro will find this tree to be, all right, if it's 50 meters tall. So if this tree is 50 meters tall, what's this angle of elevation going to be? Right now I don't know, so I'm going to put an X there, all right, to remind myself that that's what I'm looking for to solve this question. I'm going to just finish highlighting out this triangle, all right, that I'm going to be working with for this question at the bottom. All right, I got to ask myself again, is this going to be a right triangle that I'm dealing with? Absolutely. We know that trees are perpendicular with the ground, so I know that this would have to be a right angle that's being formed. So because I know this is a right angle, I should be thinking, yeah, I can use SOHCAHTOA here. I can use trigonometry to get this question done. So I'm going to write SOHCAHTOA again. SOHCAHTOA. All right. I can see here that I'm using the number 40. 40, all right, I'm going to circle, and now I have to decide, should I be using the hypotenuse, which is right across from that 90-degree angle, or should I be using the opposite side, okay, which is right across from that reference angle, that angle X? Well, this becomes a little bit tricky because a lot of you are probably thinking, yeah, I'm going to use the opposite side because the opposite side is 50. Is it 50? Let's think back to the question from before. How tall was Mr. Shapiro? Yeah, he was 2 meters tall. I can't forget that. So when I go back to the bottom here, I know that Mr. Shapiro is, again, still 2 meters tall. So I can just slide that number over here. This distance is 2 meters. I have to take 50 and subtract away the 2. If the entire tree is 50, but this piece of the trunk at the bottom is 2, that means that the leftover is going to be 48 meters. And that's going to be the second key number I want to use to get this trig question solved. Be very careful. We are not using 50, we're using 48. And now I'm ready to go. If this is the hypotenuse and this is the opposite, I know that the number that I'm left over with has to be my adjacent side. And again, it is. It's right next to that reference angle. What uses the opposite and the adjacent? Opposite and adjacent, that's going to be that tan function. So I'm going to set that up so I can solve and finish this question. So I'm really finding tan of x. X is my reference angle, which right now I don't know. All right, so tan is opposite over adjacent. My opposite side is 48. All right, and my adjacent side is 40. Don't forget, if I'm looking for the reference angle, you are not cross multiplying. You want to do that tan inverse function because I'm looking for that angle. So on my calculator, I'm going to do the inverse of 48 over 40. See what that's going to equal. So here we go. Let me just get this underneath. We got second tan of 48 over 40. Don't forget, division, all right, is really a fraction. I can type that in, close it, press enter. And I'm getting this decimal, 50.1944 dot, dot, dot. So that's what I'm going to copy over, 50.1944 dot, dot, dot. All right, but I really want to round to the nearest degree. This is going to be where I'm going to end the question. So here's the nearest degree. 5 or above, give it a shove. He is not 5 or above. He is not getting a shove. So I know that my final answer is going to be 50 degrees. And again, that's what x is going to be represented by, my reference angle. All right, awesome. Meet you on the next
All right,
page.
boys and girls, here we are. Example 3 and example 4. You now have all the wisdom you need to solve these questions independently. I need you to try example 3 and example 4 on your own. So at this point, you should really be pausing the video, not skipping through. All right, pausing the video and really trying 3 and 4 on your own. See what you understand, see what you don't understand, and then check back when you are done. All right, boys and girls, here we go, example 3. The first thing you should have wrote down at the top of your page here is SOHCAHTOA. All right, we're working on a trig question, so we want to make sure that we have those trig functions written out for us. So as we look at part A, it says, do you think it would matter which trig function you use to solve for the marked acute angle? Well, in this diagram, I can see that my marked acute angle is D, but they gave me all 3 sides. I know all of those lengths, so does it matter which trig function I use? Absolutely not. Okay, the only time it would matter is if they only gave me 2 of the sides. For example, well, what trig function uses the adjacent and the hypotenuse? Yeah, only cosine, so I would have had to have used cosine. Same thing if I get rid of the 51, opposite and hypotenuse, well, that would have been the sine function. I would have had to have used sine. And then last but not least, if I had gotten rid of the 85, that's the adjacent and the opposite, that's tan. I would have had to have used the tan function. But if I know all 3 sides, it does not matter which trig function I use. All right, so as we look at part B, we want to find the measure of that marked acute angle D. Okay, 3 different ways. So that means I want to use the 3 different trig functions. So all of the work that we have shown here on our paper, you need to show it on yours as well. You need to show the setup. You need to show that pre-rounded answer with your final answer as well. All right, so if you need to pause the video to get this down, please do that now. If not, I am cruising on down to example 4. It says, a teacher installs shelves in a classroom in order to hold textbooks and other supplies. So as I keep reading, I can see that the shelf is 10 inches from the wall, but this was already added on to my diagram. The shelf supports the braces, they're attached. At the end, it's secured 6 inches below the shelf on the wall. So again, 6 inches, it's on my diagram, right? It's below the shelf on the wall here. And then the question we always want to underline, if I want to determine the angle to the nearest degree that the brace and the shelf make, well, that's going to be this acute angle X right here. So from my reference angle, I can see that right opposite, right across is 6, so I label that as opposite. I can see that right across or right opposite my right angle is the hypotenuse. And I know that whatever is left over has to be the adjacent side. That's going to be next to, and I can clearly see 10 is next to angle X. So when I look back, well, what trig function is going to use the adjacent and the opposite side together? Yeah, that's going to be the tan function. So when I set this up, tan of my angle, right now my angle is X. I'm not sure what it is. Okay, that's going to be the opposite over the adjacent side. It's going to be 6 over 10. Now, if I'm looking for my reference angle, that's going to be the inverse trig function. All right, so you're going to press second tan of 6 over 10. And then again, just like before, you're going to show your pre-rounded answer with the final answer.
and we are ready to rock. If you guys go to the very last page, that's going to be the homework. All right, make sure that you show all of your work on the homework. You are actively working on that. And once this entire lesson is complete, you can submit it on Canvas. Have a great day.